Welcome to this lesson on collision theory. In this video, we'll explore a fundamental concept in chemical kinetics: why and how molecules must collide in order to react. Understanding collision theory is essential for explaining reaction rates and the factors that affect them. Let's dive in and discover what makes chemical reactions happen at the molecular level. Let's start with an important question. Why don't all molecules react instantly when we mix them together? If you've ever mixed two chemicals and wondered why the reaction takes time, or why some mixtures don't react at all, you're asking the right question. What must actually happen for a chemical reaction to occur? The answer lies in understanding what happens at the molecular level when substances interact. Here's the core principle of collision theory. For a reaction to occur, reactant molecules must collide with each other. This might seem obvious, but it's absolutely fundamental. Think about it. Molecules are incredibly tiny and constantly moving in random directions. When they bump into each other, there's a chance they might react and form new products. Without collisions, there can be no reaction. This is why stirring or shaking can speed up reactions. It increases the frequency of molecular collisions. But here's the catch. Not all collisions lead to reactions. In fact, molecules collide billions of times per second in a typical container. Yet, only a tiny fraction of these collisions actually result in a chemical reaction. If every collision led to a reaction, all reactions would be instantaneous and explosive. So what makes certain collisions successful while others are not? There must be additional requirements beyond just molecules bumping into each other. For a collision to be effective and lead to a reaction, two essential conditions must be met. First, the colliding molecules must have sufficient energy. Second, they must have the proper orientation. Both conditions are equally important. If molecules collide with enough energy but are oriented incorrectly, no reaction occurs. Similarly, if they're perfectly aligned but don't have enough energy, they'll just bounce off each other without reacting. Let's examine each condition in detail. The first condition is about energy. Molecules must collide with energy greater than or equal to a minimum value called the activation energy. Denoted as E sub A, this is the energy barrier that must be overcome for bonds to break and new bonds to form. The fraction of molecules that have enough energy to react is given by the exponential function, e to the power of negative E sub A divided by RT, where R is the gas constant and T is the absolute temperature. This explains why increasing temperature dramatically increases reaction rates. More molecules have sufficient energy to overcome the activation barrier. The second condition is proper orientation. Even if molecules collide with enough energy, the reactive parts of the molecules must be properly aligned during the collision. Imagine two molecules approaching each other. If the reactive sites face each other, the collision can be successful. But if they collide from the wrong angle, with non-reactive parts touching, no reaction will occur regardless of the energy involved. This is like trying to fit puzzle pieces together. They must be oriented correctly to connect. Let's summarize the key takeaway from collision theory. Successful chemical reactions require effective collisions. An effective collision is one where molecules collide with both sufficient energy to overcome the activation energy barrier and proper orientation so that reactive sites can interact. Only when both conditions are met simultaneously can bonds break and reform to create products. This elegant theory explains why reaction rates depend on factors like temperature, concentration, and the nature of the reactants. Understanding collision theory gives us powerful insights into controlling and predicting chemical reactions.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.